Hi everybody, the purpose of this video is to go over section 4 of chapter 1, and here we are going to talk about quadratic equations. Namely, we're going to talk about solving quadratic equations and the 4 tools we have available at our disposal to do that. First one is known as the zero factor property, or takes advantage of the zero factor property, however we know it as factoring. The square root property is the second one for quadratics that have the form of a perfect square. If they do not have the form of a perfect square, we can use completing the square to make them look like a perfect square and then use the square root property. And finally, we're going to talk about the quadratic formula. We are then going to touch on the solution for a certain class of cubic equations. We're going to talk about solving for quadratic variables, or taking formulas of a quadratic nature and solving them for variables. And then we're going to discuss discriminant, specifically how discriminant can tell us the number of solutions and the type of solutions in any quadratic equation. This is a quadratic equation. Specifically, this is a quadratic equation in standard form. It is basically some real number times x squared plus some other real number times x plus a third real number, and this will be equal to 0. Once again, a, b, and c are real numbers, and a cannot be 0 because if a is 0, we no longer have a quadratic equation. Instead, we have a linear equation. Notice that this equation has 3 terms. This term has no variable. As a consequence, this term has a degree of 0. This term has a variable raised to the first power, so this term has a degree of 1, and this term has a variable raised to the second power, therefore it is of degree 2. So the term with highest degree is this one, and it has degree 2. As a consequence, quadratic equations are second degree equations because the term with the highest degree has degree 2. Okay, so the first approach for solving quadratic equations is the zero property approach, or known as factoring. If you actually have a quadratic that you can indeed factor, then you can take advantage of what's called the zero factor property. And what does that mean? Well, if you have 2 expressions, whether they be numbers or algebraic expressions, and if you call one an a and the other one a and the other one b, then if their product is equal to 0, then we know that either a is equal to 0 or b is equal to 0, or if it's possible, both a and b are equal to 0. And that's pretty much what we're doing when we factor. Alright, so let's check out an example for that. Here we want to solve 6x squared plus 7x is equal to 3. Okay, before we solve this, we need to get this into standard form. And we can do that by moving the 3 over, and if we do, we will have 6x squared plus 7x minus 3 is equal to 0. And now we need to factor this. Now, the way to factor this is by using something called the AC property. And that is where we take the quadratic coefficient, which is 6, and multiply it with the constant coefficient, which in this case is negative 3, to get negative 18. Now we want to find factors of negative 18 that will sum to 7. And of course we can go down the list, but the one thing I hope you do see is that the factors of 9 and negative 2, one, they multiply to negative 18, and secondly, they sum to positive 7. So we can rewrite this, we can rewrite the middle term of 7x as 9x minus 2x, and then of course we can bring the rest of it down, minus 3, and then we would have 6x squared up here. And this will be equal to 0. And then we can use the grouping property that we hopefully are familiar with. We can group these 2 terms together, and then we can group these 2 terms together. So then minus 2x and the minus 3. And once we do that, we will have 6x squared plus 9x plus, that's group 1, negative 2x minus 3. And that will be equal to 0. Okay, notice here And now we're going to look for common factors in each term. In this particular term, we have common factors of 3 and x. So we can bring out that 3x. And then we would have 2x plus 3. Here we have a common factor of 1 plus minus 1 times, once again, 2x plus 3. Now we have two terms with a common binomial factor. We can factor out that common binomial factor, and if we do, we will have 2x plus 3 times the quantity 3x minus 1. And then the product of these two factors will be equal to 0. So that implies that either 2x plus 3 is equal to 0, or 3x minus 1 is equal to 0. Okay, well, if 2x plus 3 is equal to 0, solving this, we would have that 2x is equal to negative 3, and that x is equal to negative 3/2. Over here, we would have 3x is equal to 1, and then x is equal to 1/3. So our solution set will be negative 3/2, comma, 1/3. Okay, so that is our approach for factoring. That's actually one of the more challenging factoring problems. Okay, the next property is what we call the square root property, and it works like follows. At least according to root over here, it works as follows. If you actually had the relationship x squared is equal to k, then the solutions to that are going to be x is equal to the square root of k, or x is equal to negative square root of k. Why? Well, because the negative square root of k squared is, well, x squared. Okay, or we can write it as x is equal to plus or minus the square root of k. Okay, if that's the case, then our solution set would look like this, or MML will allow you to write it in like this, plus or minus the square root of k. But what if you have something like this? Well, if you take the square root of both sides, you will have x plus h is equal to plus or minus the square root of k. And once again, we have two equations. The first one is x plus h is equal to root k, and the other one is x plus h is equal to negative root k. Solving for x, we have x is equal to negative h plus root k, or x is equal to negative h minus root k. Okay, and therefore the solution sets will be either this, negative h plus root k, and that, or I forgot the bracket, the braces here, it will look like this. Once again, negative h plus or minus the square root of k, which just basically implies two elements. As an example, here we have 2x minus 5 squared is equal to 18. Now to solve this, we are going to take the square root of both sides. Square root here, and the square root there. And if we do that, we will have 2x minus 5 is equal to plus or minus the square root of 18. Now the square root of 18 has a factor which is a perfect square. That would be 9. So I can rewrite this as plus or minus the square root of 9 times 2. And then that will be equal to plus or minus 3 times the square root of 2. So now we have 2x minus 5 is equal to plus or minus 3 times the square root of 2. I can now add 5 to both sides, and that will give me 2x is equal to plus or minus 3 times the square root of 2 plus 5. Or I could have done it the other way. Probably should have done it the other way. So let's go ahead and do that. So that would be 2x is equal to 5 plus or minus 3 times the square root of 2. Now I can divide both sides by 2, divide by 2 here, divide by 2 here, and then that will give me the result that I'm looking for, which is x is equal to 5/2 plus or minus 3/2 times the square root of 2. And if that's the case, I can write the solution set in two ways. The first way would be 5/2 plus 3/2 times the square root of 2, comma 5/2 minus 3/2 times the square root of 2, or we can write it as 5/2 plus or minus 3/2 times the square root of 2. Now our next approach is completing the square. And that is basically used for any quadratic formula that does not look like that does not have the form of a perfect square and cannot be easily factored. And what do we do when we complete the square? Well, we essentially take the equation and we make it a perfect square. That way we can solve it using the square root property. This can be used on any quadratic equation whatsoever. Basically what we're going to do is we're going to take our standard form, which is like this, and we are going to convert it into an equation that has a perfect square. It's going to be of the form x minus some number squared is equal to beta. And once we get it into that particular form, then we can use the square root property to solve. Okay, so how does this work? Well, let's try this with an example. We're going to use this as an example. And our first step is to divide everything by a. In this case, a is 3, so we're going to divide everything by 3, and that will give us x squared plus 4x minus 3 is equal to 0. Next, we are going to move the constant term over to the other side, and we can do that by adding 3 to both sides, and that will give us x squared plus 4x is equal to 3. Now this is the important part of completing a square. We actually want to have this side to be represented as a perfect square. Right now it is not, and and as you know, a perfect square is going to have the form x squared plus 2 times ax plus a squared. Okay, and right now we have the x squared, we have the 2ax, which looks like 4x. What we're missing is the a squared over here, or this should be 4x. What we're missing over here is the a squared, which in this case would be 4. Well, let's come over here and see what the third procedure is. To make this a perfect square, we want to take half of the coefficient next to the x. We want to divide by 2, and then we want to square it. Okay, that's how we get the 2 squared here. Now if we add this to this side of the equation, we need to do the exact same thing to the other side of the equation, and that is where the 4 comes in. Notice how I keep this symbolic, basically 2 squared, but over here I keep it as I actually evaluate it and keep the real and keep the evaluated number for that. Okay, now step number 4 is to recognize that, hey, this right here is a perfect square. This is x squared plus 2 times ax, which is basically 2x, plus 2 squared. This is going to be equal to x plus 2, the entire thing squared. And that's actually what we get here. Okay, and if you expanded this, you would get that, or you would get this. Now that we've noticed that, notice here we have a perfect square. We can take the square root of both sides. And that, of course, is step 5. So here we are. Let me actually back up. We have x plus 2, the entire thing squared, is equal to the square root of 7. That will reduce to x plus 2 is equal to plus or minus the square root of 7. Okay? Well, then we can subtract 2 from both sides, and that will give us x is equal to negative 2 plus or minus the square root of 7, which is what we have here. And that is basically the approach for the square root for completing the square. Okay, well, let's try that on an example, and here it is. Here we want to solve 9x squared minus 12x plus 9 is equal to 0. Now, since we have a non-zero a term, the first thing we want to do is divide everything by 9. And if we do, we will have x squared minus 4/3 x after you simplified everything plus 1 is equal to 0. All right, there you go. That's step 1. What about step 2? Well, for step 2, we are going to move the 1 to the other side. So that will give us x squared minus 4/3 x is equal to negative 1. Now, in step 3, we want to take this coefficient, we want to divide it by 2, and we want to square it. And that will give us x squared minus 4/3 x. Okay, so 4/3 divided by 2 is going to be 4/6. So plus 4/6. And now we're going to square the entire thing. And that is going to be equal to -1 plus, well, 4 squared is 16. 6 squared is 36. All right. Notice how this can be reduced. They both have common factors of 4. So I can rewrite this as -1 plus 4/9. And that will be equal to 9/9, -9/9 plus 4/9, which is -5/9. Okay, so now here, this is a perfect square. And also notice that 4/6 is equal to 2/3. Okay, so we can actually write this in its perfect square representation, which will be x minus 2/3, simplifying here, the entire thing squared is equal to -5/9. Okay, now step 5 is to solve using the square root property. So we will have x minus 2/3 is equal to the square root of -5/9. That's going to be equal to I times the square root of 5/9, which will be I times the square root of 5 divided by 3. All right, so, oh, and I should say that this is, I'm sorry, I forgot the plus or minus, and the plus or minus here. So we have x minus 2/3 is equal to plus or minus I times the square root of 5 divided by 3. And then finally we can add 2/3 to both sides, and we will have that x is equal to 2/3 plus or minus I times the square root of 5 divided by 3. And there we are. The solution set, well, once again, the solution set will be 2/3 plus or minus I root 5 divided by 3, or you can state both terms explicitly. So that right there is completing the square. The next approach we have is the quadratic formula. And actually, if you complete the square using this representation for a quadratic equation, you'll actually get this as an answer. So we actually derived the quadratic formula by basically completing the square on the standard form of a quadratic equation. As a consequence, since this is an application of completing the square, it can be used on any quadratic equation anyways. So cool. Here's one that we can use it on. Here we have 2x squared is equal to x minus 4. Okay, well the first thing we need to do is to write this in standard form. And that would be 2x squared minus x plus 4 is equal to 0. Now notice that here we have that a is equal to 2, b is equal to -1, and c is equal to 4. All right. So with that, we can actually go ahead and state the we can actually write out the quadratic formula. We know that our two solutions for x are going to be equal to -b, which is 1, plus or minus the square root of b squared, which is, well, 1, minus 4 times a times c, which is 32. All divided by 2 times a, which is 4. Okay? And then we can simplify. We will have 1 plus or minus the square root of -31 divided by 4. Since we have a negative square root, we can replace the negative sign with the imaginary number. That will be 1 plus or minus I times the square root of 31 divided by 4. And there is not much else you can do. That's as far as we can take this. So our two solutions will be 1/4. Well, actually, hang on a second. There's actually one more thing we can do, because remember, since this is a complex number, it needs to be written in standard form. So that is something that we can actually do. So we can write this as x12, comma 2 is going to be equal to 1/4 plus or minus I times the square root of 31/4. And if that's the case, our two solution sets will, our two solutions will be 1/4 plus I root 31/4, comma 1/4 minus I root 31/4. Now notice that these solutions are complex conjugates of each other, and you will find that to be rather consistent or completely consistent whenever you are solving a quadratic equation and the number happens to be complex. Okay, another thing that you're going to see in this particular section is our cubic equations, namely equations of this form. And notice that this equation is of the form x minus a cubed is equal to 0. Okay, the question is how do you solve such an equation? Well, I'll show you after I talk about the degree. Notice since the term of highest degree is 3, this is a third degree equation. And as a consequence, it could have as many as 3 solutions. Okay, and let's do this example. Now, since we actually have an equation which is essentially x cubed minus 5 cubed is equal to 0, it follows that x equals to 5 is such a solution. Okay? If that's the case, then we can actually divide x minus 5 by x cubed minus 5, because if x equals 5 is a solution, then x minus 5 is a factor of this. So let's do x cubed minus 125. And the first thing we want to do is we want to multiply x minus 5 by x squared. If we do, we will have x cubed minus 5x squared. We can change the sign and add, and if we do, these cancel. We have 5x squared minus 125. Okay, now to get 5x squared, we need to multiply x by 5x. So I'm going to do plus 5x. All right, that will give me 5x squared minus 25x. I can change the sign and add. These cancel. I have 25x minus 125. If I multiply x minus 5 by 5, I will get, well, I'm sorry, 25, not 5, 25. I will get 25 times x, or 25. 25 times minus 5 is negative 125. I forgot the x. And then when I do the subtraction, I get 0. So it turns out that x cubed minus 125 can be written as x minus 5 times x squared plus 5x plus 25. Okay, so we need to figure out the solutions to this quadratic right here. Okay, but that's where the other two solutions would be. Now, this is not something that you can factor. This is something we're actually going to either complete the square or use the quadratic formula. So let's go ahead and use the quadratic formula. Here we have a is equal to 1, b is equal to 5, and c is equal to 25. Okay, so we're going to have that x12 is equal to negative b, which is negative 5, plus or minus the square root of b squared, which is 25, minus 4 times a times c, which will be 100. And all this will be divided by 2. All right, well, this will give us negative 5/2 plus or minus the square root of negative 75 divided by 2. We can rewrite this as negative 5/2 plus or minus I times the square root of 75 over 2. And now, one factor is 75. The highest factor is 75 that has a perfect square. Well, that is 25. 25 times 3 is 75. So we can write this as negative 5 over 2 plus or minus I times the square root of 25 times the square root of 3 divided by 2. Okay, well, the square root of 25 is just 5, and this will give us that x1 or 2 is going to be negative 5/2 plus or minus I times 5/2 times the square root of 3. And therefore, our two solutions will be negative 5 plus I times 5 over 2 root 3, comma, negative 5 over 2 plus minus I 5/2 root 3. Okay, so those are our two. Those are our two of the solutions, and of course, then I actually forgot the third solution. Let me go ahead and include that if I can. And remember, the third solution is right here. We also have that x equals 5 is a solution. So these right here, 1, 2, 3, are our three solutions for this particular example. Okay, now we want to talk about solving variables or solving equations that are quadratic in nature. One such equation might be the free fall equation, where the distance that you fall is going to be equal to 1/2 times the acceleration due to gravity times t squared, where we will solve for t. And what we want to do, well, we want to isolate that variable of interest. And what tools do we have? The same tools we have for actually solving for solving the problems that we have solved before, namely factoring, the square root property, completing the square, and the quadratic formula. So here is a problem that you might find during your homework. It is s is equal to 1 over 125 gt squared, and we want to solve for t. So how do we do this? Well, the first thing is we isolate t, and we can do that by multiplying both sides by 125 and dividing both sides by g. And if we do, we will have t squared is equal to 125 times s divided by g, and then we just take the square root of both sides. And if we do, we will have t is equal to plus or minus the square root of 125 s over g. Okay, well, now we have a couple of problems with this. The first one is that we have a square root in the denominator, and we do not like square roots in the denominators. We need to rationalize this. We can do that by multiplying both sides by this, or multiplying top and bottom by the square root of g. Square root of g here, the square root of g up here. If we do, we will have plus or minus the square root of 125 times s times g. And in the denominator, we will have the square root of g times the square root of g, which is simply g. Okay, we're still not out of the woods, because here we have 125, and this actually has factors that are perfect squares. Namely, one factor that's a perfect square of 125 is 25, which is 5 squared. Okay, we can actually write 125 as 5 squared times 5 cubed, for lack of a better term. So with that in mind, we can substitute, and that will give us that t is equal to plus or minus the square root of 25 times 5 times sg divided by g. Well, the square root of 25 is 5, and this brings us to our final form, which will be plus or minus 5 over g times the square root of 5sg. And there you go. This would be the answer. If you want to write this as a solution set, that of course would be 5 over g root 5s g, comma, negative 5 over g root 5s g. And there you go. Now the last thing that we want to talk about is the discriminant. Now here is the quadratic formula. This right here is what we call the discriminant. And the discriminant is useful for determining the number and the type of solutions. Number and type of solutions. For example, if your discriminant ends up being a perfect square, 1, 4, 9, 16, 25, whatever, then you're going to have two solutions and they will be rational. If your discriminant is positive but not a perfect square, so it's positive but not one of these numbers, that you're going to have two solutions and they will be irrational. If your discriminant is 0, you will have one solution, it will be rational, and it will be negative b over 2a. If the discriminant is negative, then you will have two solutions, but they will be complex numbers, and more importantly, they will be complex conjugates of each other. Okay, so let's check this out in an example. Here we have the equation 5x squared plus 2x minus 4 is equal to 0. We want to determine the discriminant. Well, the discriminant is going to be, once again, b squared minus 4 times a times c. We have that b is equal to 2, c is equal to negative 4, and a is equal to 5. So this is going to be equal to 2 squared, which is 4, minus 4 times 5 times negative 4. Okay, 4 times 5 is 20. 20 times negative 4 is negative 80. That will be 4 minus a negative 80, which will give us positive 84. That is our discriminant. Notice it is a positive number. However, this is not a perfect square. As a consequence, we will have two solutions. Both will be real valued, and both will be irrational. And that is all I have for this particular video. If you have any questions, please feel free to contact me. This is Bob Boyle, signing off.